Let's begin by drawing 3 parallel lines. Next, use a curved line at the bottom to connect and cover the 3 lines so that it forms the shape of a beaker. On top of the 2 outer lines, draw an arch-like shape to represent the mouth of the beaker. Now we have 3 beakers. In the first beaker, let's draw the molecules in the solid state. Use a 360-degree protractor to draw small circles closely packed together. There should not be much distance between one molecule and another, as solid particles are tightly packed. In the second beaker, draw slightly larger circles compared to the first. These circles should be evenly spaced out to represent liquid molecules, which are more loosely packed than solids. This indicates that the liquid has a more expanded form. In the third beaker, we are representing a gas. The molecules should be drawn as random circles scattered all around the beaker, at the top, bottom, and middle, to show that gas particles are spread evenly and move freely in all directions. I am using a light blue oil pastel to color the circles, representing molecules, inside all 3 beakers. Next, I am smoothing out the oil pastel colors so that they are evenly distributed. Now, starting with the third beaker, I am using a red color pen to indicate the directions in which the gas molecules are moving. You can simply draw arrows in various directions to show the random movement of gas molecules, as they move freely in all directions. Moving on to the second beaker, I am using the same red pen to mark the directions, showing that there is a noticeable gap between each molecule. This spacing indicates that the molecules in a liquid are not as tightly packed as in a solid but still maintain some cohesion. In the first beaker, I am again using the red pen to show that there is very little space between the molecules, as they are tightly packed. This demonstrates the closely packed arrangement of solid molecules. This experiment visually demonstrates that when a solid is heated, it changes into a liquid at its melting point. Upon further heating, the liquid changes into a gas. Conversely, when a gas is cooled, it condenses into a liquid, and with continued cooling, the liquid solidifies back into a solid. These changes are referred to as the interconversion of the states of matter. Now, let's label the parts. At the top of the diagram, write heat, and at the bottom, where reverse application occurs, write cool to indicate cooling. Label the first beaker as solid ice, the second beaker as liquid water, and the third beaker as gas steam. I hope you enjoyed my video. See you soon in my next drawing session. Thanks for watching. Bye for now.